Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to the Reliability Matters podcast. I'm so glad you're with me today. Modern electronic assemblies have seen so many changes over the years. In today's era of IoT, the electrification of vehicles, the explosion in the use of bottom terminated components, the increasing implementation of electronics into harsh environments, all of this has contributed to the increasing complexity and difficulty of building electronic assemblies. While so much in our industry has changed, there is one thing, at least, that has remained constant. The one thing that has remained constant is the need for ESD, or electrostatic discharge control. There always was and continues to be the challenge of protecting components from the dangers of static electricity. My guest today is Thomas Ricciardelli, founder and CEO of SelecTech, a manufacturer of ESD flooring for the electronics assembly industry. Tom is also chairman of the flooring committee of the ESD Association. Tom earned a master's in chemical engineering from MIT and an MBA from the MIT Sloan School of Management. And today, he is my guest on the podcast. So without any further ado, let me welcome Tom to the show.
Hey, Tom. Welcome.
Hey, Mike. Great to be here.
I'll give you a little behind the scenes. You and I have met. We had dinner together at an event earlier in the year or late last year. COVID time. Everything blends.
I know, right?
Could have been 20 years ago, but I had forgotten how to pronounce your last name, so I reached out to you, and I kind of spelled it phonetically. Is this the right one? And the reason I did that is I went online. Whenever I have a guest with a name that I'm not positive of, I'd like to record the intro before we record this part of it. So I went online, and it was quite literally 50-50, Ricciardelli or Ricciardelli. And I'm like, how funny. Italian is he? How Italian? It's definitely an Italian name, but I mean, if you're holding on to those Italian roots, it's going to be Ricciardelli. And
that's right.
And otherwise, Ricciardelli. So I'm glad I got it right, and then you confirmed it by email. But that was my dilemma yesterday: is how Italian? Tough choice. How down the Italian well do we go? In today's economy, as you're well aware, probably too well aware, we suffer supply chain shortages. Everything is in short supply, and it was originally billed as a component shortage, and then it became a macaroni shortage, a Diet Coke shortage, and I know in your business you probably experienced the same thing. But there's one thing that has never fallen in this unprecedented supply chain crisis. Is one thing we've never run out of, and that is static electricity. That has remained plentiful and readily available, and an overabundance of. So that's what we're going to talk about today. But before I do that, many years, I started in this industry in 1985, and I was 25 years old in 1985, and I got my tour of a contract assembly house, and I knew nothing about this business, and they had an ESD technology program, and this is the way I thought everyone did it until I never saw it again. They hung metal cables from the ceiling in an XY pattern. So north, south, east, west, metal cables, stretched tight. And they had these metal rings that hung from the cables. And connected to the rings was a wire which went to a wrist strap of some sort. Okay. Yep. So they walked around the building dragging these metal rings.
Oh, wow.
And then if a person was walking south and another person was walking north, they simply swapped wristbands so they could keep going, right? And if they had to make a 90-degree change in direction, if they had to go east-west from a north-south route, then they had to, grab another ring and put that on and then take the other one off. And it was a bizarre. It reminded me,
Sure.
like in San Francisco, they have the streetcars, with the wires, the electric wires above. It reminded me of that, but with humans. And
Sure.
and I'm like, I guess, I don't know, maybe ESD flooring wasn't common then, or maybe they were on a budget or whatever.
Yeah.
But it made the freakiest sound as people were dragging metal on metal, everywhere they walked. It just,
Sounds
I
like a
don't know.
horror movie.
It reminded me of the scene of Jacob Marley in A Christmas
Oh, yeah.
Carol, right? When he came through the door and he was covered in chains. This is
Yeah.
what it reminded me of. It was quite bizarre. But I think we've come a long way since that.
I think so. Yeah,
Since
I
that
think so. I hope
experience.
so.
Yes, you're not selling metal loops and cables.
No.
So most people in our industry are well aware of the dangers of static. I thought I was pretty well aware of it, but in doing research for this conversation, I was quite surprised at how low that number, the voltage number, can go.
Sure.
Before we get into those details, though, just let's, for the sake of our audience, who many of which are in this industry, some of which are kind of orbiting around this industry, not quite in it. Let's give a quick tutorial, if you wouldn't mind, on
Sure.
electrostatic discharge. What is it we're worried about? Why is it harmful? How does it
Sure.
generate? All of that.
Yeah. So, electrostatics, the voltage, the charge that gets generated happens when any two materials come into contact and then separate. So you putting your foot on the floor and picking it up as you walk is a separation, and you generate a charge. Taking a sweater on, even moving in your chair, any time that happens. And the amount of charge that gets generated will depend on a lot of things. It'll depend on the materials that are touching and separating. It will depend on the humidity and other things. So it's always there. And I think you started this by saying it seems to be ever present. And we never eliminate it. Again, it's always there, but we try to minimize it. To put it in context, when you feel a shock, you're in a dry winter environment, and you feel a shock on a doorknob, that's at least 3,000 volts. That voltage that you generate just walking around in an uncontrolled winter environment it's been measured to be as high as 35,000 volts. I mean, it can get pretty high. And a lot of the things that happen, to bring it over to the electronics manufacturing environment, the things that happen in that environment likewise can generate charge. People moving, packages being opened, circuits flowing through plastic tubes. All of that is, things coming into contact, separating. And those voltages can be as high if they're not controlled. Now, another point of context, and you had just mentioned the voltage levels that can damage an exposed circuit are quite low. Many of them are under 100 volts. So you're generating, if you're in an uncontrolled situation, you could easily be generating thousands of volts. And yet the circuitry, the chips that you deal with, the devices, could be sensitive to 100 volts or less. There are many customers we have, for different reasons, they have chips or devices that are sensitive to 5 or 10 volts. So it's very, very low.
And we're not feeling 100 volts or certainly 5 or 10 volts. We have no idea.
That's right.
We feel, what's the threshold for a human awareness of static electricity? Where do we feel
Yeah,
it?
so you feel it at around 3,000 volts, right? So you feel that shock on a doorknob. That's when you start to feel it. It gets to be painful at around 7,000 volts. You can see it right in that same range where you actually see a little spark.
So if we have 100 volts or 500 volts, 1,000 volts,
never know.
we have no idea.
Never know it. Right, yeah. So even at 1,000 volts, you can do some serious damage. We'll never know it. Not ever know it. And so that's why it's so important to control it and monitor it. There are ways to monitor it. And then the systems we put in place, we qualify those systems we qualify them at certain voltages. The flooring footwear system that you would use gets qualified to prevent or control voltage on the human body to under 100 volts, typically. I mean, again, if it's a special situation where the device is handled or ultra sensitive, you could procure a flooring footwear system that would control to less than that. We have systems that we show can control to like 10 volts or 15 volts. So
Wow.
it just depends on the situation. So it's very, very low. It's very, very sensitive. It can be measured and it can be controlled.
And it's not just, when I think of ESD control, I think of a contract assembler or an OEM building boards, and they're concerned about the components on those boards. I would imagine there's also a concern about equipment that it maybe is used, like an oscilloscope, for example, or some other type of testing equipment. If that equipment, if that board is holding a charge and gets plugged into a test lead on a Keysight machine or old HP machine or something, it could blow that up. Relative, figuratively speaking, it could blow components in that too, right? It's not just the raw component on the board we're building we're concerned about. We're concerned about anything in the building that has sensitive electronics inside of it. Even if it's all packaged, that can be damaged too, right?
It can be, but when they build a board and package it, they put protection, onboard protection in devices are the chips, but the component, the thing, the machine, they all have built-in protection. And typically, there's a standard for it. And typically, they try to build these machines, whatever, to withstand up to 7,000 volts or more. Up to 7,000 volts. So. And they have these little guns where they zap, like you'll take the gun and zap the leads going into say your laptop. And they're supposed to handle 7,000 volts. Now, it's been shown that you can have things go wrong under 7,000 volts, but still like in the thousands of volts level. Like say your laptop, if you were to zap one of your inputs at 5,000 volts, you may have you may freeze. It's not going to damage it per se, but it's going to be disruptive. And we're working in another committee at the ESDA. We're working on a guidance document for the healthcare environment, where it's an uncontrolled environment. It's not a factory. You can't control who comes in and what they're wearing, and everything is the machines, the things that are used, they're all built for protection. But there are concerns. You don't want to lose data. You don't want people to feel shocks and disrupt procedures and things like that. So, in those environments, we think we can help them with suggestions that would control voltages to under, say, 2,000 volts. And that would do a lot of good in those types of environments. But certainly in the electronics manufacturing environment where there are chips, you got to be very protective.
When I think of ESD control, I think of people, keeping the voltage grounded from people. There are other sources of static buildup as well. Am I correct? In addition to just us voltage carrying people, and what are some of those others?
So, again, anytime tube materials come into contact, and so like I was describing earlier, some of these chips or devices that get fed into, say, an SMTA line that flow through a tube, if the tube is not static protected, it will generate charges. That's been shown to be damaging. You can have movement of packaging materials within a controlled environment that will generate charge. Generally plastic or insulative materials are the evildoers or whatever. So all of that can generate charge. There are, with flooring, and that's my expertise, obviously, that's designed really for personnel grounding. That's the primary purpose of a floor, an ESD floor. So that's my strength. And where these I learn a lot being part of the ESDA. The other people there know a lot about all these other things. And I learn from them. So I get enough of a sense of it to talk badly about it, I guess, be dangerous. But so there are these other things that can generate charge. They try to limit and eliminate insulators from a protected area. They certainly keep them away from the sensitive devices. That's part of the 2020 program. And there are methods to reduce charges on those types of things using things like ionization. And so again, I know enough about those things to be dangerous, and I know they work hand in hand with the other things that are used to control static. Flooring is generally kind of your primary control technology. It's like it's sort of where you start, and I like to think that every sensitive environment needs to have flooring, but there are other ways to control it, wrist straps being one. You talked about this scenario where people are walking around with these chains and loops.
Jacob Marley, Jacob Marley and the chains,
right out of an old movie. I mean, that's effective. It would work. I mean, it's not very, nice to the employees and all that. So the floor really, again, it provides the grounding mechanism for the person, but that does a major portion of your control as a floor, because it kind of puts everything on the one playing field.
Quite a number of years ago, we were designing a machine, and part of the machine had a bench on it, and we wanted to make sure that the bench top surface was ESD safe, and for other reasons, in addition to conductive surface, for other reasons that had to do with chemicals and things like that, we decided to make the bench top stainless. So my thought was, not being an expert in ESD control, my thought was, well, great, now we're conductive. And then some engineer pointed out to us that we can't just have a straight path to ground. I mean, we can't just have a metal surface and consider that an ESD safe. It's something to do with discharge rate, and we needed to throw some resistors in there or something like that. Does that make sense in your world?
So it's definitely a consideration for work surfaces. For flooring, it's a little bit different because you're grounding the person, and you have footwear, and there are all these other resistors built into that path. So with you think about how something might be damaged. So if a person builds up a charge on their body and they touch a circuit and they discharge into it, and it would damage it, right? So that's called the human body model. There's another model called the charge device model. And the theory there is that a device picks up a charge, and devices can, like, let's say you had a circuit board with devices on it, chips, and it picks up a charge through the environment in a different way. And it's not grounded, so that it's maybe picking up this charge slowly. It might have hundreds of volts, right? And hundreds of volts could be damaging, but if it picks it up slowly, it's not going to damage it per se. But now you've got this device, and you put it on a highly conductive surface. That charge is going to leave the device almost as if it had come into the device. It's the same effect, yet backwards. And so it'll damage it. So if the device gets charged to several hundred volts and you ground it and that charge leaves instantly, it's a discharge and it will damage the device. So that's the charge device model. And so for work surfaces where you are handling and working on devices, you tend to want those surfaces to be have a resistance in them. We call it dissipative, and it's measured in ohms. And it, generally the standard is above 10 to the 6th ohms in resistance, and that protects that. Now that assumes that you have to deal with charge device model. There are manufacturers of very, very sensitive components that just make sure those things never attain a charge, and they will use metal as work surface. It will certainly keep charges low. Yeah. But again, you have to worry about devices picking up a charge in other ways and then discharging too rapidly. Some people think the floor needs to be in that same resistance zone for the same reason. That's not true, because like I said earlier, number one, you're never working with devices on the floor. It's not the work surface. And
not intentionally.
And you have footwear on there. It's most ESD footwear has a resistor built into it. They're generally around 10 to the 6th ohms anyway. So the floor doesn't have that same restriction. And in my experience, if you're trying to maintain under 100 volts on the human body, you want to go with flooring that's below 10 to the 6th ohms. It's much more effective, and it's more reliable and more consistent.
I was gonna ask you. You talked about footwear. I was going to ask you this question a little bit later, but since you brought it up, it's a great segue. I've always been curious whenever I do factory visits and see customers and or whatever I'm doing, teaching a course at a company. I'm handed the old smock that hasn't been, the ESD smock that hasn't been cleaned in 10 years. It's got mystery things in the pockets, and a pair of heel straps. And
sure.
I've always thought that the heel straps were potentially a weak link in this whole ESD control program, because as humans walk, generally, one heel comes up, then the next heel comes up, next heel comes up. But generally, in a standard walking environment, there's at least one heel on the ground. So as someone's walking, you're down now to one heel, versus two, and I can totally see a situation where someone is grabbing a component reel and the component reel is on a top shelf, and the person is 5'0", and they're leaning up on their tiptoes, grabbing the component reel, and for that moment, when they're making contact with something sensitive, they're not grounded, because chances are they're not wearing a wrist strap at that juncture. Wrist straps are normally at tech benches and things like that. That seems to be a weak spot in connecting the human to your floor.
It can be.
Are there better ways to connect to your floor other than, heel straps are cheap. They're pretty much disposable. Right. You don't save them. You throw them away. So what are some of the other options? Are there conductive shoes? Or are there conductive? Can you put your foot inside some kind of vacuum form baggie that is conductive? What are the options there?
So the other options are, that are common are sole grounders. It's a stretchy thing that covers the whole bottom of your foot. Works a lot like a heel strap that has the little conductive strip that you tuck into your sock, which connects to your body. That's the same as a heel strap. But the heel strap, as you pointed out, it's just a little strap on your heel. So if you're on your toes, reaching up, even if you squat down, your heels come off the ground and you can disconnect from the floor. I've actually done testing where, I'm measuring my body voltage and I have heel straps on and I'm doing the little test and everything looks great. And then I lift I stand on my toes and my voltage on my body will instantly go to a few hundred volts, right? Which is above the limit. We want to keep everything under 100 volts. So it's a pretty quick change. Now, as soon as I touch back down, I go right back to normal. So you have to think about what the risks are and what's the likelihood, the probability that someone's going to be off of both heels and be handling a component and discharge. So I think, you pointed out earlier, the heel straps are inexpensive. They're very cost effective, and that's kind of where a lot of people start. The shoes, the sole grounders, they're more expensive, but they cover your whole bottom of your shoe, and they're very effective. Then you can buy conductive footwear. Nike makes it, Timberland, there are other manufacturers, Reebok, I know has a good line. And they're much more expensive. You might pay $100 or more for a good pair of shoes. And then you think about a heel strap, one size fits all, really. So you have one size and you got everybody covered. With the shoes, it's not the same. You got different sizes, different styles. Some people like certain kinds because of comfort and whatever. And so I know that the companies that serve that portion of the industry, they have huge inventory costs. And then the companies that allow their employees to use them for different reasons, you got to manage that, control it. And you allow certain brands or not other brands. And then one thing that plays into all of this, which is a little bit of a red herring. I mentioned earlier, lots of things can impact how much voltage gets generated. And the combination of the footwear and the floor, not all footwear works with all flooring. And it's not necessarily knowable ahead of time. So we say to customers, always, if there's a certain type of footwear you like, test it with the flooring that you're using. You have to test that combination. It's a system, and they don't all work. I was doing some exploratory testing about a couple months ago, and we had 2 different types of flooring we were testing with a number of different types of footwear, and there was one type that didn't like one of the floors. It just really did not work well. It met the specification for what footwear needs to be on a flooring that met the specification for what flooring needs to be, and we were generating well over 500 volts. So, couldn't have necessarily predicted that. So we tell people you have to test that combination.
Yeah. I would imagine that Jimmy Choo and Gucci and Air Jordans probably don't make ESD, certified shoes. Know. Yeah, you're probably relegated to more industrial brands. Let's talk about flooring, which is your specialty, and that's what your business does. And I would assume you also sell other types of flooring outside of the electronic assembly industry space as well, right?
We do, yeah.
Yeah. So, but for this conversation, obviously, we'll concentrate on ESD flooring. What are the types of floorings offered? Are there different technologies? Are there different levels of static control? Or what are the basic options that one would have to choose from or get to choose
Sure.
from when they're
Yeah.
installing a floor?
So, on the very, very sort of inexpensive end, the costs are, you have installed costs and then ongoing maintenance application costs. So the very low end at the beginning is finishes. You can take a finish, it's a conductive finish, and apply it to a floor, and it will perform adequately. Now, it won't perform adequately for very long, and it has to be reapplied and maintained. Um, but the upfront cost, that the additional application is fairly inexpensive. Um, we generally, I mean, if you're in an ESD controlled electronics manufacturing environment, we wouldn't recommend going that route. Beyond that, there are paints and epoxy resinous coatings you can put on directly on the concrete. Those range from moderately inexpensive to expensive. The more expensive systems basically work better longer, and they're tougher, hold up to heavy traffic. Those are what we call sort of resinous coatings. Then there are glue down options, mostly tiles. Most of that is vinyl. There is also rubber. Those are very, very effective. They last. Their ESD properties last forever for the life of the tile itself. You'd have to wear through the tile. Generally, very, very durable. They provide a nice aesthetic to the environment. And then you can also get glue down carpet. Mostly, you would not see that in an electronics manufacturing environment. You might see it in a lab type environment where they want some comfort. You see it often in communications environments, so like FAA towers use it a lot. Carpet.
I imagine there's some acoustic attributes to that as well, right?
Without a doubt. Yep. So provides a nice, you don't get the echoing you'd get on a hard surface like a tile or coated concrete. Those are the basic options. Now, like, we also make a line of interlocking flooring. We actually invented it, and we have a couple of different options there. So they basically perform the same function as some of these glue down tiles, but you don't glue them down. Now, one thing we try to make very clear to customers is that when you have a flooring, it's a system, and it's providing a path to ground. So if you have a glue down tile, part of your system is the glue. And so if there's something wrong with that glue,
the glue has to be conductive. Is that right?
And it has to be, and it can't, like, if the glue for some reason loses its properties or changes, it changes the system. So it's important to understand that. We've seen customers have failures because the glue wasn't applied properly, or it wasn't the right glue for the concrete that was underneath it or the subfloor. And so you have a failure in the bond, and that causes the whole thing to fail. And then when that happens, a lot of finger pointing happens. So the customer's not happy. They don't have what they want. They're blaming the tile manufacturer, but it's really not the tile manufacturer's fault. It could be this. So that you get all of that.
I would imagine there's also surface preparation
Right.
that's a pretty heavy consideration when it comes to any kind of adhesive. I'm in the cleaning business. We clean circuit boards and pre-conformal coating in many applications. So surface prep is everything in our business.
Sure.
And I would imagine the same applies to a floor. You glue a carpet down or a tile down to a dirty concrete floor. There's your insulative materials right there, right? Less conductive, more insulative.
And you could get bond failures. I mean, you have to even worry about how much moisture is coming up through the concrete from the subsurface.
Right.
That's a test that has to be done. So it's critical. And so there's another. So if something goes wrong, is it the tile, is it the glue, or is it the guy who put it in? Could be all of the above. It could just be that the subsurface, say the moisture content coming through the concrete, changed. And that does happen. And then that can cause systems to fail. With the interlock, you eliminate a lot of those risks because it doesn't have an adhesive. It's not reliant. It doesn't really require subfloor preparation. You can go over existing flooring and dirty floors and things like that. It's all built into the tile itself. It electrically connects through the interlocks. So you have a complete path to ground. It just simplifies the system, which takes away, possible points of failure.
Right.
And we sell a lot of that.
I would think the interlocking would be more practical because obviously as a manufacturing floor changes, as you get more equipment or take away equipment or whatever the case may be, one can pick up tile pieces, put them somewhere else. I would imagine they're reusable, right? As long as they're in good shape, you can pick them up and move them. I have a memory of many years ago where I decided I thought I would build a home gym in my garage, and I didn't have to use it. You just had to build it, right? That was the exercise. And part of it was this foam floor that had very simple interlocking edges to it. Everyone's seen it outside of this industry. You know, it's very common. And over the course of just literally a few months, the edges would start coming up. They weren't really being pulled together. They were just interlocked. But as some tiles began to curl, maybe based on heat and moisture in the garage, whatever, they'd start coming apart. They didn't stay together. And I thought about gluing them down, but I thought, well, that defeats the purpose. And I wasn't that committed to the exercise program anyway, so that they got thrown away. But how do you keep these things together on a production floor? I mean, you can't have edges popping up and people tripping, and hurting themselves. So I remember seeing a video that you did, and you had some really amazingly simple yet sophisticated pattern around the edge that seemed to pull the tiles together. Am I describing that correctly? Do you know what I'm talking about?
Absolutely, yeah. So we have two interlock systems. One is more industrial. It's got these like T-tabs that pull themselves together. But the other one has a hidden interlock. And if you were to flip it over, you could see it. It's like a zigzag ribbing.
Yeah, that's what I saw.
So it's almost like if you took a Ziploc, which is straight, and made it zigzaggy. It's kind of like that. And the purpose of the zigzag is that it's pulling the tile together from multiple directions. So if there's any irregularity in the subfloor, it'll compensate for that. One thing people don't quite understand is if there's no perfectly flat concrete floor, especially in a factory, and if you have like a dip in the floor along one line, that dip is longer, literally, than the area next to it. And so the tile that gets put on that has to accommodate that. When you're trying to interlock tiles,
technically it has to stretch a little bit or compress a little bit, right? Because you can't have one line off by by a quarter of an inch or something, right? They all have to be.
That's right. And it adds up. So if it's a big factory, that change can add up and you could be way off. And so to get tiles to interlock, and we learned this the hard way, because when you interlock them, they don't want to give. And so it's sort of counterproductive. So we had to design our interlock to pull itself together in a way that caused the tile to stretch and compress to accommodate all those irregularities, yet still maintain a tight seam. It was not easy to come to that result, but we did. And our tile's pretty accommodating over pretty irregular surfaces, and yet still has a nice tight seam. It stays together.
I don't want to get into pricing, nor do you, in this format. But in a generic sense, are glue down options less expensive than tiles that interlock? I would think that the more convenient something is, it kind of drives the price up, and the more permanent something is, it kind of drives the price down. Is that a general rule in your industry?
Yeah, the interlocks are more expensive. They have sort of more to them. And, when I talked about sort of product cost versus total sort of life cost. One thing that comes into play, and the manufacturers, the electronics, manufacturers who run factories get this. If you were going to do an applied product, either a coating or a glue down tile, and it's an existing facility, you have to empty the facility. You have to take all the equipment out. You have to scrape whatever's there off. Generally, you talked about preparation of the subfloor. You have to do all that, and put it a different way, it's disruptive. A lot of cases you're grinding the concrete or shot blasting it, which creates dust. All that should be done, and if you want a good permanent bond of what you're applying really needs to be done. If you think about all of that and the cost and the disruption to that, then the added cost of the interlock starts to become like inexpensive relative to the cost of the disruption, the downtime. I mean, typically an interlocking installation for an existing facility can save like 2 weeks. So if you were looking, say, a 10 or 20,000 square foot space, the interlock would be about 2 weeks faster. So 2 weeks of less downtime, 2 weeks of less disruption. You're not going to be grinding the floor, shot blasting it. So you're not going to get the dust issue that you have to control for if you're doing a glue down. In a brand new facility, you don't have any of those issues. And so the glue down options are very effective. The coating options, very effective. They do a good job. They'll last a very long time. And then if you ever have to change it, you look at the interlock, years from then. So oftentimes, the new facilities, more often than not, would be new product. I mean, glue down adhesive.
Glue down, right.
Yeah.
But something where they're adding to an existing facility or tearing out something and having to rebuild, that's probably when the individual interlocking tiles make a little bit more sense. How much floor prep? We talked about surface preparation when it comes to glue down or some kind of conductive paint or something. I would imagine there's still some degree of clean floor required even for the interlocking tiles. Am I right?
Yeah, I mean, it's not. You really don't have to do much. I mean, you wouldn't want to trap anything sort of gross under the floor. So, if, for some reason you had,
unless it was conductive gross, right? But non-conductive gross has to go.
If it were like, I don't know, something that was you wouldn't want to be under there. You want to clean it. If there are any major cracks or bumps in the floor, you'd want to, fill those.
Right.
It generally can be done pretty quickly. And then the other nice thing with the interlock, you're not adhering to it. So let's say you were to use some floor patch to patch a hole. You don't really have to wait for that patch to be fully cured before you snap tiles in on top of it.
Right. Yeah, that makes sense. Is there a difference in lifetime, product life, with the different types of ESD flooring options? Does one last less time, but it's super cheap, or and the more expensive ones last longer? What's the trade-off on cost versus lifetime, and just in general, which products give one the longest life?
Yeah, so when I started earlier, the finishes tend to last a month, 2 months, 3 months maybe. So they have to be reapplied all the time. And you have to monitor them to make sure you're in compliance. You'd be measuring the resistance of your floor quite often. So, those, again, those are fairly inexpensive. Some of the coatings are not permanent ESD properties. They fade over a few years. So more than a few months, but, not forever. And you got to keep on top of them and have to reapply them periodically. And then some of the more expensive resinous systems, you hear of epoxy flooring and now the new urethane systems, they have lifetime electrical properties. They're new additives. That's new, actually. They did not used to last as long as they do now. They're nanocomposite additives that are used to provide the conductive elements, and they last for the life of the material, which is great. The vinyl products, the glue-down vinyl products, they have lifetime electrical properties, pretty much consistent throughout the industry. The vinyl is sort of the bread and butter. It's a good product. It looks good. Provides reasonable acoustics, not quite like carpet, but it's cleanable, maintainable, durable, and lifetime electrical properties. It's just they don't, as long as you keep it clean. Typically, if we see a vinyl floor that's not performing from an ESD standpoint, it's really just needs to be heavily cleaned. It's been insulated by dirt, basically.
So I'm guessing there's two reasons one should clean their floor. One is to make it look good visually for their staff and their customers, and the other is to to make sure there's no insulating properties building up on the floor that would lose a connection to ground. But if I've seen cases where maybe the janitors pull the wrong bottle of wax out and end up putting office wax on the floor, and I would imagine that's a no-no. So tell me about maintenance of the product in terms of keeping the surface clean, what products to avoid, what products to go toward, and maybe how that maintenance, if it contributes to ESD protection, how it contributes to it, or how it contributes to the life of the product, if it does, if that all makes sense.
Yeah, so the first thing is what you just said. I mean, it does happen. People use I'd say an office generic wax on the floor, and it insulates it. It's not, you can strip it off, so it's not an unrecoverable mistake, but definitely want to avoid that. Beyond that, you can put a ESD finish on a floor. It will help make it easier to keep clean. It makes it look shiny. There are some benefits for it from a maintenance standpoint. You want to make sure you're using an true ESD rated product. There are anti-static finishes that will not give you the properties that will meet an electronics manufacturing environment's needs. Like, it won't pass the standards of S20.20. So anti-static products you stay away from. Generally speaking, I mean, we sell a finish that works with our products. You're going to want to make sure I would get a recommendation from whomever sold you the floor, and make sure you test it in-house. I mentioned earlier that not all footwear works with all things for various different reasons. You're going to want to make sure if you're using an ESD finish that your footwear, you still pass the walking body voltage tests with that. And and they are, they can be very helpful in terms of keeping the floor looking cleaner longer. We've done some testings here in our factory where we'll have our conductive vinyl, 2 different pads of it. One we've finished and one we haven't, and then we run the fork truck over it for a couple of weeks, and it's noticeably different. You can really see the difference. And then the one that's coated, it's easier to clean it when it's dirty. The finishes generally do not have, lifetime ESD properties. So if you put a finish on periodically, you're going to have to reapply it. It's the kind of thing that might last several months, before your ESD properties start to fade. But again, from a maintenance standpoint, there's a benefit to it. So it's a little bit of a trade-off. Some customers love them, some customers don't use them. Customer's choice. And we can help them with that if they ask us.
What are some of the mistakes customers have made? I'm sure in all the years you've been in business, you've seen a few mistakes. Maybe you've come in and rescued them. Maybe they went somewhere else and they made a bad purchasing decision, or they were sold bad product, or whatever the case may be. But what are some of the common either misconceptions or mistakes people make when they're choosing a specific type of ESD control program for their flooring?
Yeah, that's a long list. The anti-static thing is something that comes up a lot. Anti-static products are designed for what we call human comfort. So we talked earlier about those voltage levels. They're really designed to keep voltages below a few thousand volts. It's not for an electronics manufacturing environment. So stay away from anti-static. It's not what you want. You have to make sure that the products meet the requirements of generally, I say S20.20. You want a resistance of below, the requirement is below 1 billion ohms, 10 to the 9th ohms. For an electronics manufacturing environment, we strongly recommend below 1 million ohms, 1 mega ohm, million ohms, 10 to the 6th, all the same thing. We find much, much better, more consistent performance with all types of footwear if you're below 1 million ohms, a mega ohm, 10 to the 6th. So that's something that we strongly recommend to people. Problems that they have, other problems. Installation is a big one. Not prepping properly happens all the time. Subfloor moisture is a culprit in a lot of floor failures. There's been this misconception spread around the industry that certain floors don't need conductive footwear to work in conjunction with them. Absolutely not true. To meet the requirements for electronics manufacturing, the person has to be grounded to the floor, and the only way that can happen is if they're wearing the proper footwear. So that's become a misconception. One I mentioned earlier about, customers thinking they needed a floor above 1 million ohms because of the charge device model problem. So that's really a work surface issue, and people have, they crisscross the requirements for work surfaces with the requirements of flooring. They're different. They work differently. They do different things. Like I said, we vastly prefer customers use flooring that's under a mega ohm, 10 to the 6th ohms. It's just a much more reliable system. I'm trying to think of other common problems. Those are the big ones. I mean,
those are the poster children problems.
So the two terms I've been staying away from there are two terms, conductive and dissipative, and that's defined in the ESD literature. We're trying to get away from it. The ESD Association, when I say we. Conductive has historically meant, and for flooring, has been defined to be under 10 to the 6th ohms. And then dissipative is above 10 to the 6th, but below 10 to the 9th. So they've created those two different categories, and the category terms have been misused by different manufacturers. Some manufacturers have created their own phraseology around where the resistance level should be of the floor, and they do that to suit what their products do and provide and can do. So it becomes very, very misleading. We're trying to, as an ESD association, again, when I say we, but trying to just get people to use resistance levels. You should specify your floor to have a certain resistance level, below 10 to the 6th, below 10 to the 9th, whatever it is that you think is required for your environment. And stay away from the terms, because the terms get misused. And then to top all of that off, those same terms get used for packaging. So the packaging that's used to store circuits and whatnot. Yet the resistance levels for the packaging are different. So you think you're talking about conductive and it's not. It just gets to be too confusing. So we try to stay away from them. Everybody still uses them.
So you talk about certain industry terms that sometimes get misused. And I saw a video the other day from a friend of mine, and he was explaining, it's on the subject of ESD actually, not flooring, but other types of ESD control. And he showed the pink packaging material, pink foam packaging material, and he put a device up next to it, and all three different pieces all carried a charge. And to your point, those were anti-static foams, and they were not ESD foaming, packaging material. Even though they were pink, and we associate, if it's pink, it's safe. We can package our stuff in it, but all of them were carrying a significant charge, enough to damage components. So, I guess you do have to use your phraseology carefully. And I do like the idea of just bring it down to resistance. That's kind of that cuts through all the interpretations and accents and nuances, right? It just comes down to resistivity, since the standards are kind of based on voltage and resistivity. Measure your products based on that, and that way everyone's on the same playing field. The last question, because we're running out of time, the last question is, what do you recommend a potential customer? How do they vet a supplier of ESD products? And in this case, flooring, of course, because that's your specialty. Besides just call Tom, right? Besides that, what types of questions should a potential customer ask, and what type, if any, of due diligence should a customer or a potential customer perform to make sure they're dealing with a reputable company, one that has experience in this industry? And I don't want to give any more examples because then I'll be answering my own question, but what's your recommendation? I'm sure you've seen a lot of companies come and go in your space. So as as nonpartisan as you can get, put yourself up in the press box and look down on your industry. Right. What advice would you give customers?
Yeah, in terms of vetting somebody, I mean, you want to look at how long they've been doing it. We really like to, again, try to take myself out of it, but, companies that have a breadth of products, so you're not getting pushed into one type of material just because that's all they have, right? And we see situations, every situation's different, every customer's needs is unique, and not every product fits every application. So in some cases, those inexpensive finishes are the right answer. In some cases, the expensive multi-layer epoxy resinous coating systems are the right answer. In some cases, it's the interlock. In some cases, it's a glue down. In some cases, it's carpet. So, you want somebody who's going to give you good advice. You want to look at their experience in the industry. Certainly references. I mean, you asked me earlier about sort of the problems I've seen. I've seen a lot of problems. And part of that is because, we've got a lot of big customers who have a lot of big floors, and sooner or later there are problems, and you see them. They've had problems from prior products they've used. A lot of problems aren't product related. They're just situationally related. And you want a company that understands all that. We've certainly seen a lot and understand a lot to help give people good advice. And, one thing we really, really recommend, especially if it's a large installation, is a test pad. It could be a couple hundred square feet. We were looking at a really demanding application. I don't want to name names, but we didn't, and this was during COVID, so we did not get the opportunity to visit or vet it. And we did it all over the phone, and we never did a test pad. And the product that we sold them was not what they needed. And we ended up in a good solution at the end, but man, it was just a little sweating, some hair pulling, anxiety, because the solution that we came in with was not the right one. And if we had known and done the test pad at the beginning, we would have started with the right solution. And so, it doesn't take a lot of time to put down 100 square feet of something. If it's a big area and it might be particularly challenging due to traffic or demands in the environment, chemicals. If somebody has unique chemicals, we always suggest they test it. And we're happy to provide product for that, because it's so much better to solve the problem beforehand.
Yeah, a little investment now saves a lot of money later. On both sides, not just from the manufacturer side or supplier side, but from the customer side too. They don't want to. They'd rather redo 100 square feet than 100,000 square feet.
Right. And again, we always say to people, it's not one size fits all. So it's really important to look for a company that has multiple types of products. And it gives you more flexibility, and you feel like you're going to get the right answer. We take particular pride in being really active in the industry. Like you pointed out, I am the chair of the flooring committee. It's because I volunteer to do that. It's time. It's a lot of time. I probably commit more than a month of my time a year to that endeavor, if you were to consolidate it all in. And, I just learn so much from it with all the different people that are there. And I get exposed to all different kinds of concepts outside of flooring. And we're just committed to the industry. I mean, it's very important to us. So I think if you're looking for a company, you kind of want to look for somebody who makes that commitment.
Yeah, I totally agree. We do the same thing in our part of the world for the electronic assembly industry. We work with the committees and speak at the conferences and things like that. I had a friend of mine, I call them civilian friends, people who aren't in this business, that said, "Man, you do a lot of public speaking. You go to a lot of meetings. How much do they pay you for that?" And I'm like, "We're in the wrong business if we think we're going to get paid for that, right?" It's a kind of pay it forward, right? But I like you. I'm a big believer in be part of your industry. Don't just sell to it. Be part of it. Be the industry. Right. And it definitely takes a lot of work, takes a lot of investment and time. And some of those standards meetings are extremely frustrating. You want to grind glass in your eye rather than go to another meeting. But it's a great investment, and it pays off in so many other ways. You don't get a per diem, but it certainly pays off in other ways, and it keeps you close to the pulse, right? Rather than finding out that the standards have changed and now you have to change all your products, you have a seat at the table, and you're another country heard from in terms of how things should go. Well, Tom Ricciardelli, not Ricciardelli, thank you so much for being my guest today. I really appreciate it. You've informed me of a lot. You filled in a lot of the blank spaces in my ESD knowledge, so thanks for doing that. And for my listening or viewing audience, if you'd like to get a hold of Tom, I'll have his contact information and company information in the show notes. If you're listening to this on your favorite podcast app, just go to the show notes and you'll see it. If you're watching this on YouTube, just look down where it says see more, click that button, and I'll have contact information for Tom. Tom, thank you so much for agreeing to be on the show today. I appreciate your knowledge in ESD flooring, and I appreciate the work you do on the committees to keep our products safe.
Thanks, Mike. I love this. This was a lot of fun.
Same here. Thanks a lot, Tom.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, and on our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. You can send comments and episode suggestions to Mike at mikeconrad.com. That's Conrad with a K. And be sure and subscribe to the podcast on your favorite podcast app. Or if you're watching this on YouTube, click the subscribe button and the bell icon to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of each month. Once again, thanks for listening. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks. Thanks for watching.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.